Hello everyone. So today we are going to try to prove that the limit as n goes to infinity of the sequence 3 over n squared plus 1 equals to 0. Okay, so let me just start by recalling what it means for a sequence to tend to a limit L, or for a sequence to converge to L, as we like to say. So in red we have the limit as n goes to infinity of a sub n equals to L. That means that given epsilon greater than 0, so epsilon is just some number, any number, real number. There exists a number, capital N, that is in the natural numbers. So just let me explain a couple things about my notation here. This backwards E means there exists, stands for those words. That there exists a number, capital N. That little e that you see there, that stands for that's the word n, and this right here stands for the natural numbers. So given epsilon greater than 0, there exists a natural number n in the natural numbers, such that for any n greater than or equal to n, so lowercase n greater than or equal to capital N, let's say it that way, this implies that an minus L, the absolute value of an minus L, is less than epsilon. Okay. So when we are trying to prove one of these statements here, we often want to, we're given this, someone has given that to us, we're given the epsilon. What we're looking for is the capital N here. That is what's going on there, okay? That's what you need to find. And often when doing these types of proofs, it's easier to start with what we call the conclusion, okay, which we often call the scratch work. And the conclusion itself is that whole absolute value of an minus L is less than epsilon. That's what the conclusion is. And you work yourself forward to get a statement with n. So an here is 3 over n squared plus 1. That's the sequence. Your limit is L is 0. So you just write that as is less than epsilon. And then here's what we're going to do. We're going to do a series of steps using algebra to get to a place where I have n greater than or equal to something. That's lowercase n greater than or equal to something specifically. So here's what I'm going to do. I'm going to go ahead and go to the second step here, put my n minus L. Well, if you subtract 0 from anything, it's just whatever you have. That absolute value of 3 over n squared plus 1, that's just always a positive expression here. Okay, so I don't need the absolute value. So let's take that statement, 3 over n squared plus 1 is less than epsilon. And I'm going to do this a little differently from what a lot of books would do. A lot of books or professors, they'll go ahead and they'll actually solve for n algebraically from this point. We'll put it this way, we're still going to do it, but more like steps and kind of mechanically here. So what I'm going to do here, I'm going to do this a little differently. As I said, I want to get some statement that has n less than or equal to. The cool thing about a lot of the time with sequences, it's in functions as well, but especially with sequences here, you can go ahead and take something away from your sequence, quote unquote, and make it easier to work with in a sense. So here's what I mean by that. If you take 3 over n squared plus 1, and if you were to take the 1 away from the denominator, and you look at the fraction 3 over n squared, 3 over n squared plus 1 would be less than 3 over n squared. And why am I saying that? Well, if I set that 3 over n squared to be less than epsilon, working with this expression is going to be easier than working with this one and the epsilon that I had, what I had up here originally, okay? Yeah, just by that little detail, it makes things easier for you. And eventually, my argument that I would have with that 3 over n squared less than epsilon, so I'm going to work with this. That's going to work out for me because of something we called, it's called a relation here. And when you have a less than, an inequality like a less than, if you have one thing that's bigger than the other, and that thing that I have in the middle is bigger than something else, the inequality still holds. That 3 over n squared plus 1 would still be less than epsilon, okay? So again, I saw there you could make your life easier by getting one component away, which was that 1, And we're gonna work with that statement. So 3 over n squared is less than epsilon. So here's what I'm gonna do. I'm gonna do some algebra. I'm gonna go ahead and take the reciprocal of both sides. So n squared over 3 is greater than 1 over epsilon. N squared is greater than 3 over epsilon. N is greater than the square root of 3 over epsilon. Okay, so you have quote unquote chosen, or you can choose your quote unquote n here. So I'm going to choose my n to be greater than the square root of 3 over epsilon. Okay, and that's how that works. Why? Again, because the conclusion was the following. Yeah, so I'm looking to choose my capital N, and but all of this is based on the fact that little n is greater than or equal to that capital N. So it's basically like, think of it setting these two statements equal to each other in a sense. Okay, so we found our quote unquote big N, and here's where a lot of teachers would say, you know what, this is good enough, we can stop here. But I'm going to go just a little further, and here's why. Some teachers will be like, no, you're not done yet. You actually haven't proved anything here. What you've done is you found a good choice, a good candidate, but I actually want you to make sure that this value of n that you chose is going to work out. So here's how this works. So my proof works like this. So given epsilon greater than 0, let n be a number greater than the square root of 3 over epsilon. And just, you know, to put this in like quote unquote practical terms, you plug it in epsilon like 0.1, 3 divided by 0.1 is 30. So the square root of 30, you'd pick a number, a natural number, any number greater than the square root of 30 is what kind of like what we're saying here would work out when epsilon is 0.1. Okay. But anyways, moving forward. And I'm going to do this. Consider any n greater than or equal to n, which is greater than the square root of 3 over epsilon. And we've done like 90% of the work. This part usually is just going to be some algebra. Excuse me. And the way this works is I'm going to just work backwards. N squared is greater than 3 over epsilon. N squared over 3 is greater than 1 over epsilon. 3 over n squared, so if I take the reciprocal of that, that's less than epsilon. Yeah, so again, if you take the reciprocal of two things, two natural or two positive numbers, the inequalities switch around. And last but not least, 3 over n squared plus 1, that's less than 3 over n squared, which is less than epsilon. And therefore, 3 over n squared plus 1 minus 0 is less than epsilon. Yeah, so one last step there, which was I took the statement 3 over n squared plus 1 less than epsilon, and I just put in a 0 in there. And yeah, that's this, when you subtract 0 from something that doesn't change anything, and we take the absolute value of something that's always positive, that's always positive. But anyways, that's technically, that's what these steps is the proof. However, if you just saw what I did here with the quote unquote proof, it's just working backwards with what we did, okay? And essentially the proof, the way I wrote it out, it's a little bit of a template. We kind of always begin with the given. It's a really bad G there. Let me write that. So you're given epsilon greater than 0, you let capital N be greater than the square root of 3 over epsilon, and then consider such. And then this is what happens here. Excuse me. And yeah, so there are other ways of doing these proofs. I just wanted to present you one way. I mean, I would definitely look at any other resources and see what you feel most comfortable with. But the reason I kind of like this method where I made this intermediate step right here where I will work with that other inequality instead is that it's just easier to work with in general when you have less terms. And often the way you get less terms is by excluding something from a fraction. Okay. Anyways, I hope this helps. Thank you for your time.